In part 1, we used MIDAS meter for positively identifying through valve leaks, troubleshooting as we called it. In part 2, we're going to focus on the higher value proposition of leak rate quantification. This is really important because you're not going to try and stop your process production every time you find a tiny leak. With this technology, you'll want to take a top-down approach to maintenance resources deployment, where you start by fixing the biggest leaks first. In order to inform that decision-making process, you must be able to quantify all through valve leaks. What we're now going to show, this time, is not just the readings on the LCD screen here, but we're going to capture decibel readings at key positions and do a complete survey so that we can then quantify the through valve leak rate and compare that to an allowable leak rate for that valve asset. The conditions for surveying a valve are consistent. We need the valve to be in the closed position with a differential pressure of at least 1 bar, preferably higher, and we need to know what the process fluid is. For example, liquid or gas or steam. The decibel readings taken by the MIDAS meter handset are going to be sent wirelessly to the supporting smartphone device, where we've also entered some basic details such as valve type, bore size and pressure class. So you can see we've set our target valve up in the system already. It's valve number 3 on our demo panel here, tag number TV003. We're now going to run through the test as guided by the automated software routing. First, I will press on valve number 3. You can see new survey has popped up, so we'll select new survey. The MIDAS meter is switched on and we want to add a new survey, so we click yes, and it will now make a link directly to the MIDAS meter. In this case, we're using MIDAS meter with serial number 0128 at the end. It's in calibration. It's a blue box. If the device goes out of calibration, that box will turn red. So that protects you against using an out of calibration device. So let's select our MIDAS meter. Establishes the link. The first thing you will see is that our live reading on the MIDAS meter handset is now replicated at the top of our smartphone software. To complete the survey, we're going to take readings at 5 key positions. So let me first point out those 5 positions. We start on the upstream side of the valve at the upstream far position. We then move to upstream near. Because this is a small valve, we only need 1 reading on the valve body, which we'll take directly as we did before in troubleshooting. Then we'll take 1 reading downstream near, and our final reading will be taken at downstream far. In each case, we're still going to want to use a little bit of silicon to give us that good coupling and a nice clean reading. To make this nice and easy for the user, the software is designed to talk you through the survey at each stage. It will tell you where to take the reading and how many readings to take. The way we activate that is to click on Route. So you can see here all of the positions I described, and at the bottom, Begin. So I've now clicked Begin. The first reading it asks for is background, and it tells me I want 1 reading. The background reading is essentially taken in air to verify that the sensor is working fine. So we should see 21 plus or minus 1 decibel if the sensor is working correctly, and in this case it is. The switch at the front has an H and an S. H is for hold, S is for send. Because we're happy with 21 decibels at the background position, I can now press send. You hear the noise, it's transferred those 21 decibels into that background position with a time and date stamp. The red text previously is now green, indicating that we have the correct number of readings at that location. I then want to hold the H button for 4 seconds. You'll hear a new noise. It's moved to the next position. So we can now see that it's looking for at least one reading at the upstream far position. So let's take our reading off this nice flat fitting here. Again, place the sensor on, hold it nice and steady, wait for the number to stabilize. 28 decibels is stable. I can now send that over. Again, all our text has gone green, indicating we have the correct number of readings. I press H again to move to the next position. We now want to take the reading at upstream near. So upstream near. You can see as we move closer towards the sound source, the decibels are increasing. Just let it stabilize there. We capture 39 there. Again, you can see the captured number 39, everything's gone green. Move to the next position with H. It's now looking for at least one reading on the valve body, so there's some silicon there already. Let's just go straight on. Stable at 53 decibels, we'll capture that. H, move to the next position. Downstream near, use a little bit more couplant because we've not got any on there. Again, all the time you can see the number live on the smartphone screen as well. Quite stable at 37, 38. Jog forward one more time to the downstream far position. This will be our last reading in the survey. You can see we've already lost a lot of decibels just in a short space of distance. And we'll capture that at 25. So, H one more time completes our survey. You hear a double beep. You can now see that we also have at the bottom of the screen a button for pressures. We need to tell the system how many bars of pressure we have differential across that one valve. So if we look up at our pressure gauge, you can see that's about 4.5 bar. So I click pressures. I'm going to type in on the upstream side 4.5, and on the downstream side we're coming out through the flow meter to atmosphere, so I'm going to put 0 there. Click update, get rid of the keyboard. So we now have a complete survey, and you can see that my analyze button, which was grey before, is now dark blue. It's activated, and we're ready to conclude the survey and do the calculated leak rate. So I'm going to press that, and here is our calculated leak rate. So in this case, we've measured 11.2 litres per minute of leakage coming through that valve based on the decibel readings that we were able to capture, the differential pressure, and the fluid type. If we scroll to the bottom of this screen, you'll see some valve details, but you'll also see the allowable leak rate for this valve was set at 5 litres per minute. So at 11.2, we're more than 2 times the allowable leak rate. So we have a red traffic light indicating that we want to do some repair or maintenance, or maybe even replace that valve. So you can see from our demonstration, a complete survey will typically take around 2 to 3 minutes on a valve, up to around 6-inch bore. Although that could be longer, up to around 15 minutes for the largest valves in your population. That's because on larger valves, we take multiple readings on the valve body, all around the circumference of the body, to make sure that we capture that highest stable reading. You should bear in mind that the typical alternative valve leak test techniques, like pressure build-up or pressure area tests, are very expensive and very time-consuming. One of our customers advised me that it takes on average $3 to $5 million to run pressure build-up tests on emergency shutdown valves on an offshore oil rig. Imagine using MIDAS meter, just exactly as I've demonstrated here, to non-invasively survey those valves in situ and then report the through valve leak rate in a matter of minutes, thus saving the $3 to $5 million and returning that to the bottom line of your accounts as profit. All MIDAS meter survey results are stored for immediate reporting after testing, speeding up and focusing the decision-making process for valve maintenance or replacement planning. A further press of the back arrow on the smartphone device takes you back to the main navigation screen that allows you to then select reports. We shall cover report types, data management, and valve management optimization in the next video. In summary, MIDAS meter therefore removes all guesswork and focuses all remedial actions to deliver best return on investment of maintenance resources. This is particularly valuable in supporting intelligent valve management programs, which we shall cover in more detail in Part 3. If you would like to see some real-life case studies where we've used MIDAS meter to deliver measurable value to our customers, please follow these on-screen links.